In this video, we're going to take a look at a question from the 2009 AP Chemistry Free Response test, part D of some question, but that specifically deals with bonding and intermolecular forces. So in D it says two types of intermolecular forces are present in liquid HS2, and they are LDFs, London dispersion forces, and dipole-dipole forces. Compare the strength of the London dispersion forces in liquid H2S to the strength of the London dispersion forces in H2O. So one thing that we need to know is that the more electrons, and I'm talking total electrons, not just valence electrons, in a molecule, that will lead to stronger LDFs, and that's because there's going to be greater polarizability with the more electrons in the electron cloud. Because H2S has more total electrons than H2O, H2S must have stronger LDFs than H2O. Okay, not a terrible question, and there's lots of ways you could answer that, I'm sure. But in part 2 it says compare the strength of the dipole-dipole forces in liquid H2S to the strength of the dipole-dipole forces in liquid H2O. Hopefully you recognize that we've got hydrogen bonding in water. That's a very common thing, whether you're an AP Chem or even AP Bio. And we know that hydrogen bonding is extreme dipole-dipole. It's the strongest type of dipole-dipole interactions. So, of course, H2O is going to have the stronger dipole-dipole. So I'm just going to go ahead and answer that, and then I'm going to explain why. So oxygen is the second most electronegative element. Thus, the OH bond in water has a larger dipole moment than the SH bond.